Hi, I'm talking about the algorithm that we have developed to control the elevator movements in two different kinds of buildings. The first one is a residential building in which we have a column of two elevators. The user at the entrance or at each level called the elevator, and inside the elevator we have a floor request button. The other case is the commercial building, the modern elevators in which we have the several columns. Each one is dedicated to uh, specified floors. And the difference is that in the case of commercial, there is no request button inside the cage, and the user needs to define the destination either at the ground floor, enter the final destination, or at the floors, it asks just to go down to the ground floor. The main program is quite simple. There are just 3 lines in case of the residential, and also 4 lines in case of the residential commercial. First, it listens to the user for a call, and it returns the user position and user direction. And the most tricky part is to find the elevator and to assign it to this user. The logic for the residential is that the best case, the ideal case, is that the elevator and the user are at the same place and going the same direction, and the elevator is still open. So we can assign it directly to the stop list of the elevator. Or other good cases are the elevator and the user are going to the same directions, and the elevator has not yet arrived to the user position, or the elevator is idle. And in both cases, we can add this elevator to the good cases, and finally we can find the best case depending on which one is closer and which one has the shortest stop list. But there are other cases that makes it a little complicated. In this case, which the elevator and the user has different conditions, so we cannot add user directly to the stop list of the elevator. So I decided to define a new buffer list for each elevator. So, and in this case, we add the user position to the buffer list. At the end of the travel for the elevator, it replaced the stop list with the buffer list. In case of the commercial, it's a little bit different. So I decided to calculate the distance, and this parameter, distance to go for each elevator, and then I can compare these parameters to select which elevator has a smaller distance to go parameter, and then I assign that elevator to this user. Again, the ideal case is that same direction, same position, and the elevator is still there. The other cases, they are depending on the user direction, elevator direction, and elevator position. In relation to the user position, there are 8 different conditions for which it's look a little bit complicated at the first look, but the 2 of these cases are very simple. So elevator and the user has the same direction, and the elevator has not yet arrived again. So the distance to go is equal to distance between these 2. And in the 6 other cases, the distance to go is the distance that the elevator needs to travel to the end of the destination and then comes back to pick up the user. So having both, having the distance to go of each elevator, then we can compare and find the best elevator, and then update the stop list of that elevator in these 2 cases. And in these cases, in this case, we add the user position to the buffer list, which has the same concept as the residential. Then going to move sequence of the program of the algorithm. It's quite simple. There are some security check to check if there is something inside, there's the obstacles in the door, or if the maximum capacity of the elevator has been respected or not. And then it decides, depending on the stop list and the position of the elevator, to go move up or move down. And for example, in the case of move up, it's close the door, increment the elevator position, and as it arrives to the first stop in the list, it stops, open the door, remove the floor from the list, wait 5 seconds, and then if the user asks for another floor which is in the direction of the elevator, it adds it to the elevator stop list, and repeat until the end of the list. At the end, it checks if the buffer list is empty or not. If it's not empty, it will replace the stop list with the buffer list. And if it's empty, it goes to change the elevator state to the idle. And that was a brief description of my algorithm. Thank you.